Folks, welcome to Statistics. Alright folks, welcome back to the next lecture in statistics. What are the 5 pillars when it comes to describing quantitative data? Let me tell you: shape, center, spread, context, and outliers. Let's go ahead and take a look at those 5 pillars. So first is shape. How do we describe the shape of a histogram? Well, answering that question is going to answer how we describe the shape of quantitative data. Let's go ahead and take a look at some histograms to answer that question. Alright, so here's our first histogram here. Let's call it histogram A. And what do you notice about histogram A? Well, you notice that it has very few data values here. Well, when that occurs, we call this a right-skewed histogram. We call this a right-skewed distribution of data. We say it's right-skewed because there's not many quantities to the left, to the right of the distribution. So you're going to notice this kind of a trail at the end or at the right of our distribution, and this trail is actually called a tail. Okay, and so we call this a right-skewed distribution because there's not many values over here on the right side of the histogram. Pretty self-evident. Now, we can also look at this from a different perspective. This is about right-skewed and left-skewed, but we can also take a look at this from the perspective of modality, and let me show you what that means. Alright, so here we've got another histogram, and let's call this histogram B. What do you notice in this histogram? Well, you notice there are 2 peaks, 2 humps, 2 big data modes, and we call these data modes, since we have 2 modes over here, we call this a bimodal distribution of data. So what do we call this? We call this bimodal because you've got 2 modes. Okay, pretty self-evident. This is called a bimodal distribution of data, as opposed to a unimodal distribution of data where you would, for example, have only 1 peak. Okay, so you would no longer have this second peak in a unimodal distribution. You'd only have this 1 peak. Okay, so that is how we can describe the shape of a distribution. We can say it's right-skewed, we can say it's left-skewed, we can say it's unimodal or bimodal. But before we leave off the shape, there's one more thing to consider, and that is symmetry. Now, here's the consideration we need to make about symmetry. If a shape is symmetric, you say that when you fold it over its axis of symmetry, it'll look virtually identical on both sides. We can make exactly the same consideration when it comes to histograms. Let's take a look at what I mean by taking a look at 2 histograms. Alright folks, so what do we have right here? Well, we have our 2 histograms. We have histogram A in purple and we have histogram B in red. Now, I just said we can make considerations about symmetry from these 2 histograms. Do you see which one is symmetric? Well, from your eye, it probably looks pretty obvious that it is indeed A, histogram A, that is symmetric, because when you fold it over this kind of edge, this axis of symmetry, you'll get pretty much the same result on both sides. It looks symmetric. So this over here is a symmetrical distribution of data. Okay, symmetrical distribution. That's what we mean when we say distribution or histogram or quantitative data is symmetrical. On the other hand, here we have asymmetric data. Asymmetric data. And why do we know it's asymmetric? How do we know it's asymmetric? Well, as you can see, there's no kind of edge or axis of symmetry you can flip over to get the same image. One more thing, we can be even more specific. You can see the tail of your histogram is to the right side, and so what you can make, you can deduce this is a right-skewed histogram. Also note that just because I haven't shown it, it doesn't mean that left-skewed histograms don't exist. As a matter of fact, they're pretty frequent. So that's how you describe the shape of quantitative data. You can say it's left-skewed or right-skewed. You can say it's symmetrical or asymmetrical. You can say it's unimodal or bimodal. And those are just some of the adjectives you can use in describing the shape of quantitative data. Let's now check out the next one of the 5 pillars, which is center. Now it's time to talk about center. what do I mean when I talk about center? Well, center is the most typical value or the most typical data value in some kind of a data set. So for example, let's say you're the average person with 5 computers in your home, but someone else might have 4 computers or 9 computers in their household. The typical value or the center would be the value that most people have, the number of computers that most people own in their households. To give you a better sense of what I mean, let's go ahead and draw a histogram that explains this idea. Okay, so I got this distribution here, this histogram right over here. Let's call this histogram A. Now, what if I want to find the typical value in this distribution, in this histogram? Well, let's say this is a histogram that represents the number of computers a certain household owns. So the number of computers, or the number of Macs a household owns. So for example, if you're a particularly affluent household, you might own 9 Macs. If you're a particularly poor household, you might own 0 or even 1 Mac. Okay, now that's shown across this data. You can see it's a kind of bimodal distribution we've got right here. But what I'm really concerned with here is the typical value. What's the value that most people have? And to answer that question, I'm going to kind of put this distribution on a scale, on a kind of weight machine. And that weight machine, it's almost like a fulcrum. It's going to tell me where this histogram kind of balances. And that balancing point, just for the sake of the diagram, just for the sake of visuals, it could be this point right here. That balancing point is the point that separates, it's the point that demarcates where exactly half of the population is. So for example, let's say this over here is 3. What does that mean? That means most people, or the typical individual, would own about 3 MacBooks in their home. Okay, so 50% of people own less and 50% of people own more. This right here, this typical value, this center of the distribution, as we like to call it, is called the median. Okay, so most often we may use the median as the center of the distribution. In later lectures, you'll learn that there's other measures of central tendency that can describe the center, but for now the median is the name of the game when it comes to describing the center of a histogram, or the center of a quantitative distribution of data. Okay, so that right there is the median, and just to sum it up for you, the median is the central value. It represents the typical value in a data set. All right, that's it for center. Let's go ahead and take a look at the next one, which is spread. What is spread? Let's check it out. But before we go to spread, let's talk a little bit about how we actually calculate the median for an even group of numbers and an odd group of numbers. So turns out calculating the median, or the center, or the typical value in a data set isn't too bad. Let's take a look first and foremost at the easier one, the odd batch of numbers. So let's say I have an odd batch of numbers. I don't know. Let's say I have 5, 6, 7, 8, 9. As you can see, I've got 5 numbers here, which is odd. How do I find the median? Well, I just take the number of values in my data set, and what's that going to be? Well, it's going to be 5, and I'm going to divide it by 2. And what's that going to give me? That's going to be 2.5, but I'm going to take the ceiling of that number. The ceiling is just the smallest integer greater than or equal to this number, and that's going to be 3. And of course, look at the third value, and this right here is indeed my median. All right, what if instead of having 5 data values, we had an even number of data values? Let's say I had, I don't know, 4 data values or 6 data values. So let's say I started with 2, 3, 9, 12, 14, 18. So just for your convenience, I've sorted out the data values. Remember, when finding the median, you should always sort out your data values in ascending order, least to greatest, and I've done that right here for you. Now, given these 6 numbers, how do I find their median? Well, it turns out it's not too bad. If I try to perform the same calculation I did with an odd number of numbers, what do I find? Well, 6 over 2 is going to give me what? 6 over 2 is going to give me 3, but check it out. If I take my third number, which is 9, I end up with 3 numbers to the right of 9, but only 2 numbers to the left of 9. So clearly this 9 guy is in the center. It's not the median. And clearly I don't know where my eraser has gone, but that's perfectly fine. Oh, here's my eraser. Okay, so we've now declared that 9 is not the median. So what do? Well, we pick the value adjacent to 9, and that's going to be 12. And now we're going to take the average of these two guys. What's the average of 9 and 12? Well, whatever it is, it's going to be the median of this data set. So it's going to be 21/2, which is basically 10.5. That's going to be the median of this data set. And that, folks, is how you calculate the median for an odd number of numbers and an even number of numbers. For an odd number of numbers, you just look at the value that's a half of however many values you have. So for example, if you have 5 data values, take its half, take the ceiling, look at that number, and that's going to be your median. If you have an even number of numbers, just take the average of the n/2 and the n/2 plus 1 data value. Okay, let me make things clear for you. Look at your n/2 data value. N is the number of data values you have. And look at your n/2 plus 1 data value and average those guys up, and that's going to give you your median for an even number of numbers. Okay, that's how you calculate the median. Now let's take a look at spread. Spread. No, it's not like spreading butter on peanut butter and jelly, but it is very much like range and interquartile range. That is the name of the game when it comes to spread. Okay, so let's go ahead and take a look at that. Let's go ahead and take a look at spread. Okay, so let's say I've got a bunch of numbers. I want to start first and foremost with numbers. Okay, so 1, 2, 3, 4, 5, 6. All right, the easiest 6 numbers I could have possibly chosen. These 6 numbers have a certain range, right? These are data values and they have a certain range. What's the range of these data values going to be? Well, it's going to be the maximum value minus the minimum value. Okay, well, that's not too hard. The maximum is 6, the minimum is 1. Who am I kidding? It's just going to be 5. That's my range. Now, range isn't as easy as it looks. There's a lot of subtlety to it because the greater your range, the greater the variability of your data set. So it's not always good to have a great or a high number of range or a big range, okay? Now we can also calculate something called interquartile range. Interquartile range is basically how spread out your middle 50% of your data set is, okay? So let me go ahead and show you how to calculate your interquartile range, also known as IQR. Okay, so how do we calculate interquartile range, also known as IQR? Well, first and foremost, we're going to take a look at the median. What's the median of this data set? Well, how many data values does it have, even or odd? 1, 2, 3, 4, 5, 6. Even. So take the average of your middle values. Okay, and so that means my median is 7/2 or 3.5. Okay, so that's my median. That is the median of my data set. That is the median of this data set, 3.5. But things get subtle, ladies and gentlemen. Things get subtle. Because this right here is the median, but we want to calculate the interquartile range. And that's going to be the spread of the middle 50% of your data values. So now we need to calculate the median of this guy and the median of this guy. Okay, well, that's not too hard. The median of this guy over here, well, that's just going to be the middle number 2. Median of this guy, that's just going to be the middle number 5. And so now you're starting to get a clearer picture of what's going on. Okay, so this is your lower quartile. This is your upper quartile. Okay, so we can actually give these names now. We call to the lower quartile. Lower quartile, also known as the 25th percentile. 25th percentile. We call 3.5 the median. The median. It's also known as the 50th percentile. And finally, as you might have guessed by now, we call 5 the upper quartile. And we correspondingly call it the 75th percentile. So what's going on here? Well, things aren't too bad. What we're really seeing right here is that 50%, the middle half of our data values, lie between 2 and 5. And hey, that should make sense, right? Because only 1 and 6 lie outside of that. Well, what else do we know? Well, we know that the interquartile range is going to be 5 minus 2. It's going to be your upper quartile, also known as Q3, minus your lower quartile, also known as Q1. So it's going to be 5, your upper quartile, minus 2, your lower quartile. And so your interquartile range will simply be 3, ladies and gentlemen. And that right there is how you calculate the interquartile range and the range. Now, before we leave it off at that for spread, why is spread so important? Well, spread tells you how far apart your data values are. If you've got a very low spread, a very low range, a very low interquartile range, it means most of your data values are centered close around the mean or the median. As opposed to the fact when you have a very high range, it means your values are spread out all over the place. You don't know where you're shooting for. All right, folks, that's it for spread. Now let's take a look at outliers, all right? What's the name of the game when it comes to outliers? Well, you always have to discuss outliers. And as a matter of fact, to show you just how critical, just how crucial outliers may be, I want to give you an example of the airline industry, which, as you know, has suffered terribly from this pandemic. But even before that, let's take a look at how often customers cancel their airline flight. All right, folks, so this right here is the flight cancellations of passengers from 2000, or I don't know, from 1995 to 2005, okay? So over the course of a big decade. Okay, well, what's happening here? Well, let's try to describe this distribution of data. First and foremost, what we see is this is a unimodal distribution, unimodal. How do we know that? Well, there's only one peak, right? So it's unimodal. What else do we see? Well, number 2, we see that it's right skewed. Because the tail is over here, we can conclude that this is a right skewed distribution. It's asymmetric, it's not symmetrical. But one more, and just as important thing we can conclude, is this outlier. Where is this 20% outlier coming from? When did over 20% of the American public cancel their flights? Well, turns out that's a very important date. It's 9/11, ladies and gentlemen. That was the day that over 20% of Americans canceled their airline flights. And that's why you see this big outlier. And so that's why it's so important to discuss outliers when it comes to interpreting, discussing, and summarizing your quantitative data. All right, so that's outliers. We just discussed outliers, the 4th pillar. What's the 5th pillar all about? Well, the 5th pillar is really a kind of idea. It's the idea of context. You should always discuss context, right? What is your data about? Who are you collecting data on? What's the x-axis about? What's the y-axis about? What's the kind of goal of the data? What are you trying to visualize or communicate? Okay, that's the name of the game when it comes to context, which is the 5th pillar of quantitative data. All right, folks, so ladies and gentlemen, you now know how to use the 5 pillars of quantitative data. What are they? Hopefully you know by now. Number 1, shape. Number 2, center. Number 3, spread. Number 4, outliers, which we just checked out. And number 5, context. We'll check you out in the next lecture of statistics.